All right, hi guys. This is take 3 for me, or 4 or 5, I don't know. I'm struggling to be my own filmographer, whatever you call it, I'm sorry. All right, so last week we focused on fan cart physics, or you created a launcher. What you should have discovered is that the more force you added to the object, the farther you were able to make it travel. When you started adding mass to it, it slowed it down and it didn't go as far. This is when, so launching things in the air, gravity is working against you. It's trying to pull you down to the ground. When you're rolling along the ground, gravity is creating friction, slowing you down again. Now we're gonna try a new setup because we're going to test out an idea, because your younger sibling has come up with you with a bet. You challenges you to come to Churchill when there's snow and sled down our big hill down in the back. And whoever can go, when you get down the hill, whoever slides out farther is going to win. The winner gets their room cleaned for a month. So you kind of want to take this deal, but you don't want to clean your sibling's bedroom for a month because you know that sometimes they hide things under their bed that you don't want to find. Maybe a bowl or rotten milk or something, and you don't want to worry about that. So you want to make sure that you're going to win. So we're going to test out on an incline when gravity's helping us. Gravity is helping us speed up. So when you slide down a hill, is more mass gonna help you and make you travel farther, or is more mass going to hurt you and you're not gonna be able to travel as far? Okay, so with our lab, I've got a large steel ball bearing. This is 1.5 inches. The next size is 1 inch. Then 1/2 inch, and my little tiny baby one is 1/4 inch. They're all made of the same material, so the bigger one has more mass. I will get the masses for you back in class. We'll put them on a scale and put it on the paper so you guys will have the masses. Now we're gonna run it through my simulation here. So here's my incline. And then I've got 4 meter sticks set up to help me measure how far the balls roll. And I've got my meter sticks set up in centimeters. Centimeters is much easier to measure than in inches. Inches, when you try to break them up, ends up in fractions, and fractions are just hard. So I like to keep it to decimal points, and centimeters allow us to do that. Okay, I'm gonna start with the smallest. We're gonna run 4 trials of each. I'll call out how far it goes, and then we will calculate the average of them. So, set my camera up so we can see it. Give me just... Use my little stand here. Okay, we got a pretty good view here. So I'm gonna start with the smallest one, this one here. It is, can I see it? This is 1/4 inch. Okay, this went to 89 centimeters. Okay, trial 2 went to 93 centimeters. Trial 3 went to 92 centimeters. Trial 4, ooh, not as far. This one's 89 centimeters. Okay, put that one away. Okay, marble 2. This is the 1/2 inch. Give you an idea how big it is. Okay, trial 2 went to 154 centimeters. Trial 2 is 155 centimeters. Trial 3 is 141 centimeters. Trial 4 is 143 centimeters. Now calculating the average for marble 2, you'll take just the 4 numbers from marble 2, add them all up, divide by 4 to calculate the average. Now we're gonna go to the 1-inch ball bearing. This is about the size of a shooter marble. Not the regular marbles, but the ones they would use to knock them out. Oops, that failed. Okay, 204 centimeters. Are you guys starting to see a pattern of what's going on here? $215 centimeters. $219 centimeters. Oh wow, this one went 233. So once again, add the 4 numbers up, divide by 4 to calculate your average. Okay, the last one. Can you make a prediction? Do you know how far this one's gonna travel? Is it just gonna be too heavy now? Is it going to work? Or is it going to win? Is it going to travel the greatest distance? Okay, 265 centimeters. $263. Okay, 250 centimeters. Okay, let's go ahead and take a look at this one. So here, each meter is 100 centimeters. We've gone 2, starting our third one, so 200. And I like to kind of go right in the middle, so I'm going to call this 270 centimeters. This is all our data. Once again, with the large marble, you're going to add up the 4 distances, divide by 4, and calculate an average.